Hi everyone. This little video is about stoichiometry. Don't get scared by the term stoichiometry. It's something that we've been doing when we have been analysing all of our experiments that we've been doing in the recent weeks. So stoichiometry is just about the study of quantities of materials consumed and produced in chemical reactions. So we know that a balanced chemical equation is like a recipe. We need to know what the ingredients are and what relative amounts of ingredients are needed for both recipes and chemical equations to work. So if we think about the experiment that we did this week, the molar volume of gases, we reacted magnesium metal with hydrochloric acid, and we produced magnesium chloride and hydrogen gas. If we balance this chemical equation, we now know exactly what ingredients we need and how much of each of those ingredients we need for that chemical equation to work. So a balanced chemical equation can tell us many different things. And we're going to have a look at both the microscopic level and the macroscopic level. So looking at this is our representation of the chemical reaction. We have our reactants on the left-hand side of the reaction, and we have our products on the right-hand side of the reaction. This equation is reacting ethanol with oxygen, which is combustion of ethanol, and it's producing carbon dioxide gas and water vapor. So if we look at it at a microscopic level, we can read it as 1 molecule of ethanol reacts with 3 molecules of oxygen to produce 2 molecules of carbon dioxide and 3 molecules of water. So very simple way of looking at it. If we look at it in a macroscopic way, we can say that 1 mole of ethanol reacts with 3 moles of oxygen to produce 2 moles of carbon dioxide and 1 mole of water. Another way we can look at it macroscopically is to look at the number of particles that we've got that we need in this particular reaction. So this now reads 6.02 times 10 to the 23 molecules of ethanol reacts with 3 times 6.02 times 10 to the 23 molecules of oxygen to produce 2 times 6.02 times 10 to the 23 molecules of carbon dioxide and 3 times 6.02 times 10 to the 23 molecules of water. We can also think about it in macroscopic terms, such as the masses that we use for each. So macroscopically, if we start with 46 grams of ethanol, which is the molar mass of 1 mole of ethanol, it reacts with 96 grams of oxygen, which is 3 times the molar mass of 1 mole of oxygen, to produce 88 grams of carbon dioxide, which is 2 times the molar mass of 1 mole of carbon dioxide. It will produce 54 grams of water, which is the same as 3 times the molar mass of 1 mole of water. And that's going to happen in proper conditions, under proper conditions. So theoretically, if we use 142 grams of reactants, we should produce 142 grams of products. We know experimentally in our high school labs, it's very rare for us to do that. But we know in chemical reactions that atoms and masses are conserved, but the moles and molecules are not. So what that means, let me go back. What that means is that it's the law of conservation of mass. However, if we look at a chemical equation that has, if we're reacting only gases, here we've got 2 moles of hydrogen gas reacts with 1 mole of oxygen gas to produce 2 moles of water vapor. So at STP, if we combine 45.2 litres of hydrogen, which is 2 times the molar volume, with 22.7 litres of oxygen, which is 1 times the molar volume, how much should we produce? Now, if you're going to say 68.1 litres of water vapour, then you would be incorrect. And that's because when we're talking about molar volume of a gas, remember it has a constant at STP. So we're only going to produce 45.4 litres of water, and that's 2 times the molar volume of water. So unlike mass and atoms, volume is not conserved.